maybe it'd be good to recap. I tried to rewrite these a little neater or a little more in order, maybe of what your thought process might be on this. So if we want to, let's just, because I'll probably reference this as we talk about the homework problems. So maybe this would be good. So this would kind of be the thought process I would go through. Now, again, one of my goals today is to work through one where we don't even think about this at the beginning. Now, I typically want to do this, but you could just kind of blindly, you see it's an SSA one. It's an ambiguous case, right? Remember, if it's an angle, side angle, or an angle, angle, side, if there's two angles given, then there is no ambiguity. I mean, it's going to be one triangle, right? So if there's two angles given, angle, side angle, or angle, angle, side, law of sines works great because you don't have that missing angle that you have to do sine B equals, and there's two possibilities, quadrant 1, quadrant 2, that whole thing. I mean, you don't get into that. So a lot of times law of sines works just fine. It's this ambiguous case. So we spend a lot of time on it, but then I think sometimes people think that they have to do that all the time, right? That's not true. Only when you determine you've got an SSA situation is when you think, okay, here we go. And so you can either do this or you can just blindly start in on the problem. And what will happen is you'll get an error if there's no triangle. You'll find one that'll be an acute angle, and then you'll have to subtract that from 180 and say, well, there could be a second triangle, and you have to work that out. And then at some point you'll be like, oh, wait, this second triangle doesn't work. So now there's just one, right? I mean, that does work, okay? So the only problem is if you have some problems where they just ask you, is there 0, 1, or 2 triangles, then you've got to kind of go through a lot of work maybe to get to that answer, but whatever. So anyway, to recap, so I would look at it like this. Nice looking through. All right, so if we've got this right here, so again, if I prefer to always put the angle that you're given in the far left, the one across is always that swinger, the one we're not sure about. Is it going to be too short? Is it going to be too long? Is it just right? Whatever. Is it going to make 2? That's always the one across. So if you happen to get a picture, maybe on some of the story problems we do today, where you have to, draw the picture, that's what we're going to work a lot on today, is getting the right picture drawn for a story problem. But you draw it and you just don't have that angle down here in this corner. Just keep in mind, if it's an SSA situation, the swinger, the one that we're debating about, if it's too long, too short, whatever, that's always the one across from the angle. Then the other side is the one you do the B sine A with, right? Whether it's called B or not, doesn't matter. It's this times sine of that. It's this times sine of that. So you don't use the swinger, right, when you're doing that B sine A, that height thing. Okay, so if it's not set up perfectly this way, you can still do it. All right, so again, too short. So the first thing I would look for is, okay, is this side long, right? Is this side longer than this side? So if we go back to my recap, so right away, I look at the swinger. If it's more than the other side, then I'm like, okay, we only got one triangle. No. So if this side here is longer than this side, then we have one triangle every single time, no matter what. So right here, and then you notice down here. Now, so we have a little different situation. If your one angle you're given is obtuse, you can't have 2. There's just no way. So if the given angle down here is obtuse, you cannot have 2 because you can't have 2 obtuse triangles, obtuse angles in triangles. So if this is obtuse, if the swinger side is bigger than the other side, then for sure you have one. For sure you have one. Okay, and away you go. But most of the time you don't have that situation. You have A is littler. Okay, so if A is littler than this other side, then it's possible you don't have any. If it's less than this height right here. Okay, so that's the next thing I look at. So if A is less than the B sine A, then you don't have any. Okay, now in the obtuse one, you can't have 2. We've already said if A is bigger than B, you have 1. If A is less than or equal to B, you have none. Right? You don't have any, because if A is the same as B, it won't be long enough to reach this side down here. Right? If this is obtuse and A is littler than B, it's going to stop here somewhere. You just can't. It won't be long enough. okay? So this can be 1 or none there. But most of the time we're up here in this situation. So if A is bigger, you know you got 1 triangle. If A is less than the height, the B sine A, you know you don't have any. If A is equal to B sine A, that's when it's perfect, right? I mean, if it's just perfect. So when I get this to, had it. There we go. So if it's just exactly equal to the height, well, that's when you know you've just got 1 right there, okay? And then if it's greater than, but it's not more than B, and of course you already took care of that here. So if A is greater than the height, but it's not greater than B, right, which we've already taken care of here. If you know that if you know this side is more than this side, you know you have 1 right away, you can just move on. Move on and start working the problem. So if this side is more than this side, you know you got 1 triangle, just start working it, okay? But if it's not, then you check and see, and if it's greater than the height, that's when it's going to swing through here, and you're going to have 2, and that would be this situation here. So 5.7 is less than 9. We check the height is 4.5. 5.7 is more than the height, so that means there's going to be 1 over here and 1 over here. And those are your 2. Yes?
These could be like A could be C or B could be.
Exactly.
It doesn't have to be.
Right, just the way I have it set up. The way I've got this set up is the swinger side is always across from the angle, because you only know 1 angle, right? SSA, you only have 1 angle. And one of the angles is across from it, or one of the sides has to be across from it, right? I mean, otherwise, if you didn't have this side here, if you had these 2 sides, now you got side angle side, it's a whole different deal, right? So one of the sides has to be across from the angle, and the one that's not across is the one that you put with the sign to do the height. Yeah, so they don't have to be A and B and so forth, right? I always call it B sine A, just because I always refer back to this, but even if they're something different, that's what it is. It's this side times the sine of that angle. That's always going to be your height. Okay, so again, if that clicks and you can go through that, then use it. Okay, but if you don't have to, that's fine. Okay, here's the even ones. I thought I'd throw up these answers if you want to check them. I don't know if you took pictures of your thing here, but on the homework you had some odds, and then these are the evens. So 10 had 1 triangle, 18 had 2 triangles, and 26 was no triangle. Okay? All right, anything you want to see out of any of that? The odds, even, whatever. Seth?
Number 29.
You had trouble getting one of the answers, you mean?
Yeah, I had trouble getting the second set.
So A is how much?
58 degrees.
Okay. And what else?
Little a is 11.4. And then B is 12.8.
Okay. So, again, this side's the swinger side, and it's littler, so that's okay. So it could be 2. It depends on how's it compared to this height. So B sine A would be 12.8 times sine of 58. What is that? Did you calculate that?
Yeah.
How much? 10.8 something. So that means if it was littler than the height, if it was littler than that, we'd have nothing, right? We'd have nothing. It's too short. But now it's okay. So what's going to happen, and I don't know if you want to draw this in like that. You know, that sometimes can be helpful. When you're going to have 2, it's this scenario right here, right? It's 5.7 here, and it's also 5.7 over here. Okay, that's what's happening. Your height here was 4.5 in this example, so it was more than the height. So it would hit over here, and it would hit over here. So I, a lot of times, will draw that kind of that isosceles triangle, right, which tells me that these angles are equal here. Right, now that was A. What did they call this side here, the 12.8? C? Was that little C? That was little B. So that would be big B over here, and then C, just so I make sure. Okay, so I would go sine of 58. I'm always going to use that 58 and 11.4 in every calculation if I can, because those were given to me, so I know I didn't mess anything up. And then I want to find angle B, so sine of B over 12.8. So when I cross multiply, I get sine B equals. Anybody got that written down?
0.952.
Okay, so B would equal, you hit inverse sine. Hopefully you keep that unrounded. If you use the answer key, that's your best bet. If you're having any trouble with your calculator and the rounding part of that, please talk to me today. What do you get? 72.2. 72.2. So that would be there. Now, how you fill this in, I don't care. If this is 72.2, if you think of your little isosceles, you think of that swinger here being on these two different places, you could say, well, this is going to be 72.2 also. And so therefore, what's this got to be? That's got to be 180. So our second triangle, let me put it in blue. So here's our second triangle right here, right? The red, the big red is our first triangle. This is our second. So this has to be 180 minus 72.2. So 107.8, right? Now, the other way to do it is just to automatically just subtract from 180. Because that's how it is every time. It's 180 minus 72.2. So it's 107.8. Now again, that's because sine of 0.952, sine is positive in the first and second quadrants. So it's kind of like you're finding a reference angle here. That's the other way to think about it, is when you find that 72.2, you found a reference angle, and sine is also positive over here. So you got to have, so that's 180 minus 72.2. Okay, so you can think of it this way geometrically, or you can think of it this way with reference angles. Okay, and now back to this. If I'm going to go with this one, then I would set up a sine of 58 over 11.4. So does that fix it for you, Seth? Or is there more of it yet? Was it just getting that second angle?
I think I just messed up in general.
Okay, so now I would go sine, I would probably go sine of 72.2 divided by 12. No, wait, what am I doing? That was stupid. Okay, sine of 58 over 11.4. And then the one I'm missing here is, now I need C, right? So sine of, what would this be up here now, the red? That'd be 180 minus 58 minus 72.2. How much is that? How much? 14? No.
40.
The big, the red one.
49.7.
There we go. 49.8. Okay. That'd be this whole angle here, because you got 58 here and you got 72.2 here, and so you got to have 49.8 up there. So angle C would be 49.8. Okay, and so now you have sine of 49.8 over little c, right, which would be this side down here, and what'd you get for little c? 10.3. Should be smaller than those. That sounds about right. So that would be that one. And then the blue one, so now in the blue one, we'd have sine of 58 over 11.4, and we would have sine of what's left for this little angle up here. That's the one you guys are saying was 14.2. Yeah. So that one's 14.2 up there. So now you'd have sine of 14.2 over little c. So now that'd be the little c right there. And that would be c. I'll put it over here. Little c would equal probably pretty small, right? 8.3? 3.3. 3.3. And then what was big C? Big C was 14.2. Yeah. Okay, now if we had not done the whole B sine A thing, how would this have looked? Here, so let me summarize. If you just if you want to double check or you want to make sure you're not confident on the whole 1, 2, or 0 thing, then what this could look like, let me do it in black, is you could have just started, well, let me just redraw. You could have just went like this. You could have said, okay, this is 58, this is 11.4, this is 12.8. You could have said, all right, sine of 58 over 11.4. I'm just blindly heading into this. Call that B. So I got sine of B equals 12.8. You go ahead and do this. Your calculator gives you, what was it, 72.2. And at that point, now, so what would have happened is, if you do this and you do inverse sine and you get sine B equals 1.8, you go inverse sine, syntax error, right? What do you know? Nothing, right? No triangle. So you get an error, you know, no triangles. If you get an answer, 72.2, then you could assume, okay, there's a second one. Okay, B is, and you do 180 minus 72.2, that's 107.8. Now, at this point, what will happen is you say, okay, now let me go find this other one. Well, what happens if this angle here is like 74? Well, what's 74 plus 107.8? More than 180, right? So so as soon as you look for that second angle, right, you always subtract from 180. So you find your first one, it'll always be a first quadrant angle. Law of sine's always going to give you a first quadrant angle. You get that. Your second potential angle is going to be 180 minus that. And so then when you put that in, when you go to find your third, you'll find out that those two are too big. The one you were given and this new one is too big. And that's why if it's obtuse, that's why if this one's obtuse, there's no way your second one's going to work, right? There's no way when you find your second angle here, when you subtract from 180 is going to be obtuse. There's no way that it can, that'll work with the obtuse one you already have. So that's why when there's an obtuse one to start with, you can't ever have two triangles. Okay, so now you take this one, you go to find the third, and you say, oh, that's too big. It goes over 180. So you cross it out, and you say, I can't have two. Must just have this one. Okay, if it does work, like in this one, then you have two, right? So that is a way to do it. I think you guys are too smart and too good to just rely on that. I think you should understand how this whole thing works, why there's two, why this swinger angle, might be big enough, might not. I think that's a value. But at the end of the day, when you work the problem, you can get by without doing it. Okay, so now when you take 58 and 107.8 and you subtract it, you get 14.2, then it's like, okay, yeah, this does work. Okay, this will work, and you find the rest of your stuff. Okay, so that is a possibility for you to do. All right, let's go through. Okay, so feel pretty good about the law of sines, though. I mean, going through. Okay, we have to work a ton of because we got some story problems. I'm going to spend some time on it. Let's do this though. I want you to go through here and with these. And just for practice on this B sine A, the whole height thing, I want you to tell me how many triangles there's going to be here. Let's do that for a few problems here real quick. How many triangles are going to be for this one?
I think you paused it instead of freezing the screen.
That's what I did. Okay, who's not here?
I didn't.
Everybody's here? All right, well, it's not spring break yet. So, come on. All right, 21. So back to this one. 15 was littler than 27, so then it was a matter of, okay, it's littler than 27, but is it littler than the height? And it turns out it was littler, so we didn't have anything. Here, it's bigger. We know we're going to have one. We know we're going to have one. Okay, anytime that the swinger side is bigger than that side, you know you're going to have one. Okay? All right, and then I went ahead and calculated. We don't even need to worry about that height. Okay? All right, what about this one? Okay, how many? This one has 2, right? So again, you look at this, 10 is littler than that, but then the question is it littler than the height? Is it too little, like the first one we did? Well, it turns out that B sine A is 8.48. 12 times sine of 45, that height right here is going to be 8.48, so 10 is bigger than that, so it's going to have a triangle here, and it's going to swing over here and have one here. Okay, and so that's why you're going to get the 2. Okay, you're going to get the 2, and I went ahead and computed those out. Okay, last one. Last one. 0, 1, or 2. How many? Whenever you have a 100, when you have an obtuse angle here, now you don't have to draw it to scale, but it's nice when you're trying to decide if it's 0, 1, or 2. Whenever one is obtuse, you can't have 2. You cannot have 2. Okay? So there's no sense even doing the B sine A thing. You're only going to have 1 or none. And the whole thing is this is bigger than that. Right? If this is smaller, that swinger, it's going to be like here. It's not going to be long enough, and it's not going to make a triangle. Okay, you could make another one over here, but that's not, we can't, I mean, that doesn't count. It's got to be inside of here. Okay, it's got to have this 100-degree angle. So since 70 is greater than 20, you know it's going to be 1. Okay, if the 70 is smaller, you know it's going to be none. Okay, can't have 2 when that first angle you're given is obtuse. All right, let's focus on some story problems here so we can have some more time to work. So let's see what you remember about drawing bearing. Let me give you a hint. North 30 east. North 30 east. You go up north, and then you go 30 to the east, which would be to the right. And so you would go there, and 30 would be right in there. So these are always given with north or south first. So the angles are always going to be drawn next to the y-axis. It's the reverse of our reference angles. Reference angles we always draw along the x-axis. Bearing problems, north, east, that kind of thing are always drawn up in here. Okay? All right, so that's my refresher. See if you can just draw this picture. And of course, the secret then at the end of the picture is to locate a triangle, right? The triangle that they are talking about, and it's going to be oblique generally. Now you'll have some little triangles within triangles probably. We'll probably need to be doing parallel lines, things like alternate interior angles. We're going to use all kinds of geometry kinds of things here to get these pictures drawn correctly. And then once we identify the triangle that we're looking at, that's when we'll determine our law of sines and how we'll find the things we need. Okay, so let's see if you've got a picture yet. Now here's what I would do if I'm reading this. In the homework, many of the problems are going to give you the picture. Okay, on the quiz, I may do one where I give you a picture. I may do one where I just give you this and don't give you the picture, and you have to draw the picture. Okay, but if I'm reading this, I'm first going to get a sense of the whole problem. So we start at point A, and we go southwest, so that's down and to the left. Okay, then from there, we're going to go southeast. That's down and to the right to point C, and then back to point A, and it says point C lies directly south of A. So that's going to make me want to put A up here somewhere, and I'm going to go south and west for a while to point B. I'm going to go south and east for a while to point C, and it's got to be directly south of A, and that's 8, and then that side is 8 kilometers. So that might be my initial drawing, without any angles or anything drawn in there. Okay, just knowing the southwest and the southeast and that stuff. Okay, now what I would probably do then is put in some kind of helper lines right here. Okay, so where's the 52 go? Where at big A? In this triangle?
No.
South, 52, west. I agree. It would be right in there. Because this is straight up, so you go from point A, you go south, and then to the west, 52. So south, 52 west. So the 52 would be right in there. Then from point B, and again, I might draw in some little helper guides here. We go south, 40 east. So where's the 40 go? Right there. The 40 goes there. South from point B, south, and then to the east, 40. So that's 40. And then we get to point C, and then we go straight back up, and we go 8 kilometers there. Okay. So, obviously that's the first key, getting that part drawn correctly. Now, what do we need? We need some stuff. We need 3 pieces of information. Right now we got 1, the side, and we got this angle. What else can we get here? Isn't this 40? Isn't this an alternate interior right here? I always remember alternate interior is like a Z, made a Z with parallel lines, kind of right there. But those would be alternate interiors right there. If this is 40, that one's 40 right there. Okay? Now, the question is, what's the total distance of the course? So we need all 3 sides, right? And add them up is what we want. Okay? Because we're going to go from A to B to C and back to A. Okay, well, what do we got? We got angle, side, angle. Well, that's perfect for law of sines, right? So sine of oh, what am I missing? What do I need to do here? I better get this angle right here, right? What's that going to be? 88, because you're going to add up 52 and 40. 52 and 40 is 92. Subtract that from 180. So 180 minus 92 is 88. So sine of 88 over 8. And then it doesn't matter. Sine of 52 over little a. This would be little a. This would be little c. Okay, and what do you get for little a? Let's go nearest 10th. 6.3. And then sine of 88 over 8 equals sine of 40 over little c. What do you get for that one? 5.1. and then we can add those up. So 6.3, 5.1, so 6.3 plus 5.1 plus 8, right? And that would be your approximation. Okay? All right, we're going to work on a couple of the homework problems here where I'm going to give you a little time to set them up. So if you want to go to a different piece of paper where your homework's going to be, it'll be a little out of order. I hope that doesn't throw you off too much. Okay? Some people get kind of crazy about that. They want all their homework to be in order, right? Never bothers me any. Okay? 47 in the book. This is on page... They've actually helped you with the picture, but I want you to draw the picture and find the angles, get all ready to go before and then when you're ready to do law of sines. So find all the pieces that you need. So this is on page 435. So we have a utility pole casting a shadow down a slope. Angle of elevation of the sun. Remember, angle of elevation is always made with the horizontal. That's angle of elevation. Angle of depression is always made with the horizontal. They're equal, right? So angle of elevation of the sun would be if you're on the ground looking up at the sun, that would be angle of elevation. Or if you're at the sun looking down, angle of depression is that, right? Angle of depression is made with the horizontal. Angle of elevation is always made with the horizontal. Okay? Like so. Now, they help you a little bit with this picture. See if we can I'll give you a few minutes to try to get they give you some of the numbers to put in, but you have to find some others. Usually it's about one. Usually there's like one measurement you somehow have to get with the given information before you're ready to do the law of sines or start doing calculations. So I've got up here basically what they have in your book. Okay? That's basically what they have in the book. But think about how if they hadn't given you that. So it says a 10-meter pole. So you draw a 10-meter pole straight up and down. Cast a 17-foot shadow down a slope. So there's where you're drawing your slope right there. That's where the 17 comes from. Okay? And it says the angle of elevation to the sun. So this is your shadow. So that means the sun would be up here. So the sun would be coming right down this line right here. Right? If that's the shadow, right, then the sun's up here coming straight down like so. So that's how that 42 gets drawn. That's why you draw this horizontal here. Because that angle of elevation has to be 42. It's not this little angle in here. It's that whole angle. Okay? That's because of that slope. What's the piece that we need to put in there to help us get going here? What's the piece that's staring us right in the face that we can easily get? Angle A right up here. What is it? 48. If you look at the big right triangle right here, you've got 90 here, and you've got 42 here. So this is 90, and this is 42, so that tells you that's 48. Now look at the red oblique triangle here. Look at the red oblique triangle. We have side, side, angle. Now, here's the thing though. If we have side, side, angle in a picture, we're not going to have to worry about two different triangles, right? There's not going to be a second triangle that's going to fit this picture with the hill, right? Because what we're going to do is we're going to find this angle right here, right? We're going to find this angle right here. Well, there's no way. Remember, the second possible angle is an obtuse. It's 180 minus this. Well, there's no way this is an obtuse angle here, right? It's not going to happen. So we know with our picture, even though it's a sort of story problem, the side-side angles usually don't end up being a no triangle or a two triangle situation because of the way it's set up. Okay? All right. So what are we going to write? Sine of 48 over 17. That would be the swinger if we were concerned about this at all, right? But and well, let's just do that, right? That would be the swinger, right? Well, what do you notice? It's bigger than the other one, right? What did that always mean? If the bigger one was big, if the swinger was bigger than this other one, it was how many triangles? It was always one, every time. Okay, so again, we know that's going to happen. All right, and then we got sine of whatever you want to call this one. I mean, they called it 42 minus 8. At the end of the day, the angle we're actually trying to find is this, the angle of elevation of the hill. Okay, but once we get this, we'll know that, right? Once we get this, so I don't call this x, I don't care, it doesn't matter. Sine x, whatever that unknown angle is. You could call it b. I mean, you could call it b. The problem is there's several angles here at b. I don't care, call it b, doesn't matter. You know which one you're talking about, I hope. You're talking about this angle here is one, because we're looking at this red triangle, okay? And then that would be 10. So what are you getting there for b? Let's go to the nearest 10. I would say if it doesn't ever say different, let's always do one decimal. 25.9. So this is 25.9 degrees right here. Okay, well that's enough. We don't have to solve the rest of it. We can now answer this question here. What's theta got to be? 42 minus 25.9 is 16.1 degrees. So the angle of elevation of the hill is 16. Okay? So noticing what, you see this right triangle, you might think it's a SOHCAHTOA. The problem is we don't have enough information. Without law of sines, we couldn't get this. We're trying to find theta. The only thing we know is the hypotenuse is 17. We don't know this, and we don't know this. We don't have enough information. But we do in this oblique triangle, right? This obtuse triangle here. We have enough information using law of sines to get it. Okay? Let's try 51. Let's see if before... So there you go. 1 of your homework problems down. Okay? Let's try 51. You have to read it, though. There's no picture given to you. right, now you can keep going on the problem, but here's what I got to start. So is angle of depression, so you got this plane coming in, now it can come in either direction, didn't really say. But you got the beginning of the runway, the end of the runway, and so angle depression, remember, always measured from horizontal, so that's why I drew this horizontal line up here. Okay, so 18.8 degrees was the angle to the beginning of the runway. Okay, 17.5 is the angle to the end of the runway. Okay, angle of depression, isn't that what it said, angle of depression? Okay, is always measured from the horizontal. All right, that was all it gave you, wasn't it? Okay, now, and then it asked you several questions about the triangle. So the triangle we're really interested in is this triangle right here, right? Because we want that 9,000 as part of it, right? There's our triangle right there. Well, what is this angle? Neither of these angles are going to be useful, right? Well, they're useful, but I mean, neither of these angles are part of this triangle, are they? So what is this angle right here? 1.3, right? That's the difference between those two. But there is another angle we know. We need one more piece of information. We got the 1.3, we got the 9,000. What else do we know? Alternate interior. This angle down here is what? This angle down here is 17.5. You got the 17.5 up here, and that's alternate interior to the 17.5 down here. So now you have angle, angle, you can get this angle, which I don't even think they care about, and then you got the 9,000 right here. So then they have several questions, okay, and then you could go from there. They say, so they want you to draw the diagram. Find the air distance it must travel until touching down on the near end. So assuming it's going to touch down on the near end, that would be this distance. That would be its air distance, right? Find the ground distance the plane must travel. What would that be? No, that's the length of the runway. What's the ground distance it travels from here to when it touches down here? That's this distance right here. That's the ground distance. Like if its shadow maybe was moving along or whatever, the ground distance the plane covers is this right here. The air distance it travels is that right there. So now you got a new triangle. That'd be a right triangle, right? But if you find this angle, you know that angle. Or maybe you already know this angle because you know this is 18.8 to here, so you know that angle, right? So you can find some stuff in there. Okay, so you start finding a bunch of stuff. The last one, find the altitude of the plane when the pilot begins the descent. Well, that would be this up here. That would be this Y. That would be how high the plane is. Okay? So, law of signs is just a tool to help us in these scenarios, but we got to be able to set them up and understand what's going on. That's what we're going to work on when we come back. I got that graded and put in the grade book.
I saw it,
Okay.
thank you.
All right, so I think the rest of the time I'm gonna let you work, and you can help each other out, and you can ask me some questions. You can come up here and look at this. So basically, that's all we have for law of signs. Now it's gonna be a matter of doing some problems with it, both story problems and just regular problems where I give you information. So here's the ones I want you to do for tomorrow. Don't ask me why I did 45 through 54 and then 55. I don't know what I was thinking there, but. All right, we'll learn about log cosines tomorrow.